This video will be on how to add and subtract surds. So to add and subtract surds, you must know about what are like surds. And like surds are exactly like the word like terms in algebra. And like terms are where we have terms that have the exact same pronumeral and the exact same power. So these are some like terms. And they don't have to be the same sign, so one term can be positive and one term can be negative, but I must have the same pronumeral and power. Well, like surds are exactly the same concept. What you need is you need the same number under the square root sign. So here we've got a root 2, here we've got a root 7. The number on under the square root sign isn't the same, so these are not like surds. Okay. In the example underneath, I can see I've got a root 3 and a root 3. They are the same number. So we've got the same like surds. So we've got root 3 and root 3, and that means they are like surds. It does not matter if the number in front of the surds are different. But what you need to be checking for is that number under the square root signs are the same. That makes 2 root 3 and 4 root 3 like surds. Now there's some harder questions like root 20 and root 24. And what you'll need to do for those is actually reduce the surds yourself. So root 20 I can change into root 4 and root 5, and then when I reduce them I'll get 2 root 5, so I'll reduce the 4 to 2. So root 20 turns into 2 root 5. Let's see what happens to root 24. I'll change the 24 into 4 sixes, put the square term first, so square number is 4. That square root of 4 reduces to 2, so I get 2 root 6. So I can see that I have a root 5 and a root 6. They are not the same, so I will say that root 20 and root 24 are not like surds. Let's try root 8 and root 2. If I take the root 8, I'll reduce that to root 4 times root 2. I'll break it into root 4 times root 2, and then I'll reduce the root 4 into 2, root 2, and then I can see straight away that I've got a root 2 over here and a root 2 there, so they are like surds. Might need a bit of space for my last example. So we've got root 28 and minus root 175. So let's write that down. Root 28, I can reduce, I can break 28 into 4 sevens. I'll put the square number first, and root 4 reduces to 2, so we get 2 root 7. Now I'll have a look at what minus root 175 is. I know that 25 goes nicely into 175, and it goes into 104 times, and then there's an extra 75, so that's another 3 times, so it must be 7. So that reduces to minus 5 root 7. And then I can see root 7, definitely like surds, so these are a yes. So why are we looking at like surds? Well, the surds that you can add and subtract or combine together to make a single term are like surds. So for example, here I've got 4 root 2, another 4 root 2, and then I'm going to take away 9 root 2. Well, all of them have root 2, so they're all like surds. So if I have 4 root 2 plus 4 root 2, that would be 8 root 2, and then I'm going to take away 9 root 2. So if I have 8 root 2s, and then I take away 9, well, 8 minus 9, that's minus 1. Now, you can write minus 1 root 2, but we don't normally write the 1, so I'd prefer you just to write it as minus root 2. Harder questions will require you to reduce each surd and then work out if you have any like surds. I don't know if I have like surds until the surds are fully reduced. So here I'm going to change the root 12 into root 4 and root 3. I'm going to change the root 27 into root 9, root 3, and I'm going to change the root 75 into root 25, root 3, and then I'm going to start reducing. So the root 4 turns into 2, so we get 2 root 3. The root 9 changes to 3, so I get 3 root 3, and the root 25 becomes 5 root 3. So I've got 2 root 3, this is where I look at how many I've got. I've got 2 root 3s. If I subtract 3, well, that'll give me minus 1 root 3 plus 5 root 3. Okay, now I can write the minus 1 over here. I'm just not going to write it if it appears in my final answer. So then I've got minus 1 root 3 plus 5. Minus 1 plus 5 is 4. So that'll give me 4 root 3. And that is my final answer to this question. So I could, turns out that all three terms are like surds, so I could combine them. All right, hopefully you're getting the idea. I would pause the video if you're feeling confident and attempt these questions, and then you can go through and press play and you'll see my answers. For those of you who are struggling, just keep listening. So once again, I want to make sure you understand the similarity between collecting like terms. So if I have 10x and I take away 4x and then I add 9x, well, 10x minus 4x is 6x, and 6x plus 9x is 15x. If we do that with surds, it's the exact same thing. 10 root 2 minus 4 root 2 is 6 root 2. Add on the 9 root 2 gives me 15 root 2. Minus 3y minus y is minus 4y. And minus 4y minus 5y is minus 9y. So the same thing's going to happen here. Minus 3 root 7 minus root 7 is minus 4 root 7. Don't forget there's a 1 there. And minus 4 root 7 minus 5 root 7 is minus 9 root 7. One more example with simplifying. So these are quite heavy, it looks. So we're going to have to simplify all these surds. So if I have a 3 out the front, I'm just going to drop that 3 straight down, and then I'm going to start breaking up these numbers. So 48 is 16 times 3. 75 is 25 times 3. I'm going to drop this 2 here. So we've got a 2, and then I'll break the root 12 into root 4 and a root 3. Then I'm going to combine, I'm going to reduce that, I'm going to reduce this surd, and I'm going to reduce that surd. So we're going to have 3 times 4 root 3, and I'm going to have 5 times root 3, and I'm going to have 2 times that root 4 becomes 2 times root 3. So when I'm combining these, if I have numbers at the front, they are joined by multiplication, so I need to multiply them. So 3 times 4 is 12, so I've got 12 root 3 minus 5 root 3, and here we've got a 2 times 2, or 2 times 2 is 4 root 3, and now I've got all like surds, so 12 root 3 minus 5 root 3 is 7 root 3, plus another 4 root 3 gives me 11 root 3. It's quite long, but if you go step by step, you should be fine, okay? Let's quickly have a look at one more. This video is getting a bit long, so I'll quickly go through one more example so you feel confident. So once again, lots of surds to reduce here. I'm going to change the root 12 into a root 4 and a root 3. I'm going to change the root 72 into root 36 and root 2. So you have to really get into a bit of practice with knowing the numbers. I'm going to change the root 18 into root 9 and root 2. Can I fit the last one in? And then the root 75, well, it's 2 root 75, so I'll drop the 2 down, and then I'll break the root 75 into 25 and a root 3. I think I'll just squeeze it in. So now I'm going to reduce all these surds. They need to turn into nice integers. So we're going to get, I might do it down here so I've got more space. 5 times, well, the root 4 is 2. Then I've got 5 times root 36 is 6. And that root 9 over here is going to be 3. And the root 25 over here is going to turn into a 5. And we're going to multiply. So we've got 10 root 2, 30 root 2, minus 9 root 2, plus 10 root 3. And I hope you're noticing that we don't have all of them being like surds. So I've got root 3's here, and I've got, let's get the other like surds. I've got some root 2's here. So let's collect the like surds. So 10 root 3 plus 10 root 3, well, that would be 20 root 3. And minus 30 root 2 minus 9 root 2 is minus 39 root 2. And because these are not like surds, so be really careful, you can see they're not like surds, that means I can't go any further. That is the end of this question. All right, boys, I hope this makes sense to you. Watch it again if it doesn't, and watch it as many times as you need to. Send me an email if you're stuck.